I am Dr.B.Shoba, currently working as professor in the Department of ECE, BSc College of Engineering and Technology. Today I am going to handle the topic about overview of 5G networks and its role in the current scenario, because nowadays, especially towards communication, we are now jumping towards 5G networks. This is the reason why I have selected this topic to discuss with you. I am going to discuss about the introduction, key features of 5G networks, architecture, applications, impact of 5G on various sectors, and especially I have taken two different applications. In case of direct to mobile 5G via satellite and ADAS using 5G, what are the challenges in deploying the 5G and what are the future trends and research areas. As we all know, 5G is the fifth generation. Actually, in wireless networks, we have started with first generation, that is purely analog voice communication. Some examples we know. It is using purely the FDMA technology. Next, we have entered into the 2G, that is second generation, where we have introduced digital voice, GSM, that is very famous. Even nowadays, many people are using that second generation mobiles, which has the digital voice introduction using TDMA, and we have introduced that SMS service in 2G. Followed by 2G, we have entered into the third generation, the main aim of introducing broadband applications in mobile. So we want to access the internet through the mobile. So in between this 2G and 3G, we are having 2.5G also, where there is a slower improvement towards mobile internet access. But actually we have developed a full-fledged internet access through mobile in the 3G. Even we are not satisfied with the performance, there is a speed, so we have slowly entered into the fourth generation, where we have introduced a high-speed internet but with low latency. Even nowadays, we are going for ultra-fast speeds and we are in need of ultra-low latency, and we want to connect more number of devices or massive number of devices to be connected. That is the reason why we have moved from 4th generation to 5th generation. So every 10 years we have started from 1st generation up to now we are in 5th generation. So most probably by 2030 we will be entering into the 6th generation. So there is an upgradement or updation of generations based on the added features. Now we will talk about the key features of 5G networks. First, let us start with the high speed. So nowadays, from the user's perspective, they are in need of high speed communication over the mobile. So peak download speeds even up to 20 gigabits per second we can able to get through 5G networks. But in the earlier 4G, it's up to only 1 gigabits per second. So the main application of this high speed plays a major role in that high definition video streaming, virtual reality, augmented reality. If we want to experience, definitely we are in need of high speed networks. So 5G is the best option for that. And for large scale connectivity, that is massive devices to be connected, that IoT applications, we can go for this 5G networks. Second important feature is low latency. So the latency as low as even 1 millisecond we can able to obtain using 5G networks. But in the earlier 4G, it was around 30 to 50 milliseconds. So the main use of this low latency is we can go for real-time communication, especially for remote surgery. Nowadays, we are talking about remote surgery, that is the patient may be at one end and doctors may be at the other end, but they can able to do the surgery. So that is possible now, because there we are in need of very, very low latency. So this is an apt application towards 5G. And we can go for autonomous vehicles. So that is again another boom nowadays. We want to have smart cities to be connected with autonomous vehicles. So 5G networks gives option for that. Next feature is massive connectivity. Where using 5G networks, we can able to connect even 1 million devices per square kilometer. So we are going for this IoT revolution, industry 4.0, now we are going for 5.0 and all. So for all these things, we are in need of massive connectivity of number of IoT devices. So 5G paves the way for that. The most important feature of this 5G is network slicing. That is, we can able to create many number of virtual networks based on the user application or need. Some users may be in need of very high speed. Some users may be in need of somewhat acceptable speed like that. So based on the quality of service requirements per user, we can go for network slicing. Energy efficiency. So this is another most important feature of 5G networks. So we are in need of efficient spectrum usage, because spectrum is very important resource we are having in wireless communication. So this spectrum can be utilized efficiently and we can have lot of power saving features. So we are having 10 years battery life for connected objects under 5G networks. So these are all the major key features of 5G networks. Coming to the network architecture of 5G, we are having two different specifications with respect to the architecture. First one is 5G NSA, that is non-standalone architecture, where the already existing 4G architecture can be utilized for adopting the 5G features. So nowadays we are having this feature only. The second option is standalone architecture for 5G. Now all the base works are started and most probably within 1 or 2 years we may have the full-fledged standalone architecture for 5G. So coming to the different networks under 5G. First one is radio access network. So where we will be having a lot of small cells which is having the massive MIMO, that is multiple input, multiple output concepts coming into picture, and we are having beam forming technologies. So if we want to focus our radiation towards a particular direction, we can go for beam forming technologies. So it supports dense networks, that is we want to have connectivity for all the subscribers within a particular area, and even it is a very highly mobility area, we want to highlight the connectivity within that particular area. So radio access network design is very, very important under 5G network. Coming to the core network, so we are using the advanced cloud native architecture with edge computing. So edge computing is a major concern with this 5G. That is, we can make the resources available to the users nearer to them. They need not to wait for, that is, remote cloud to give the service. We can have distributed computing instead of centralized computing. That is called as edge computing feature coming under core network. And we are having that slicing, network slicing application, which is mainly based on the customization of the network. That is, based on the user's perspective, we can go for different options for the networks. Coming to the transport network, fiber optic cables and high-speed backhaul networks are used. In India already we have laid fiber optic cables, so that's not a major issue for us. Coming to the 5G spectrum, so we are having 3 different frequency bands under 5G. Low frequency band, mid frequency band and high frequency band. After this low frequency band is nothing but frequencies less than 1 GHz. So this particular low frequency band finds application where we will be having slower speed, but we can have large coverage under low band. Whereas the high frequency band, just opposite of the low band, that is, we will be having the frequency range from 24 GHz to 40 GHz for this high frequency, and we can get high speed but low coverage area. So mid frequency band, which is from 1 GHz to 6 GHz, will be having the coverage as well as speed in between this low and high frequency bands. So based on the user's position, we can go for selection of a particular spectrum. So this is a diagram showing the non-standalone architecture of 5G, where already existing that 4G network, that is LTE, long-term evaluation network is used. packet core, E node B, and all the interfaces starting from UX and S1 interfaces are used as such for the implementation of 5G network. Coming to the standalone architecture, so here we have introduced next generation core network as an additional feature compared to the 4G. So all the core network we have to erect especially for 5G network. So this is the 5G standalone core network which we saw the previous slide. So it is having the parts random access network. So here we are having lot of interfaces, but most of the interfaces are not been yet defined. So research is going on. Most probably everything will be defined in a neat way. So we are having many resemblances compared to the 4G. We are having AUSF, that is authentication server function. So if you want to give access to a particular user, first of all that user should be authenticated, then only the service will be provided to that user. So for that we are using this AUSF. Then UDM is Unified Data Management. It is similar to a HSS where all the details about a subscriber pertaining to that particular area or homes is stored. So this UDM gives all the details about a particular subscriber before giving service or getting the access from the user. AMF is access and mobility function. So for any user, if you want access to the network and if they are in the movement from one area to another area, so all these functions will be carried out by this AMF, access and mobility function. Next comes SMF, that is session management function. So it is related to that network slicing. Based on the user's need, we can go for a particular session, or the network can be sliced virtually and can be allotted. PCF stands for policy control function. So all the regulatory policies pertaining to the user's quality of service will be maintained here. So especially for network slicing, all the policy function related to the user will be stored. Next comes the AF, application function. So it is a high level function that is carried out based on the user's application request. So user plane is completely dealing with the user's perspective, whereas control plane is there, that is dealing with the control functions. So we are having random access network, same data network is there. So this is the overall core network architecture of standalone 5G. Coming to the 5G characteristics, we are having massive MIMO, full duplex connection, non-orthogonal multiple access, IoT waveforms are used because this is an example of a smart city connected wirelessly, and we are using 256 wireless amplitude modulation. So everywhere will be having the connectivity. So coming to the concept of network slicing indeed, we are having URLLC, that is ultra reliable low latency communication. So we can have the reliability to the extreme level and the latency will be very low. So for such sort of communication, we can go for a separate network, that is URLLC slicing. Then comes the enhanced mobile broadband slicing. So if you are in need of any enhanced mobile features, that is broadband features, if you are in need with the special characteristics or evolved features, means we can go for this EMBB slicing, evolved mobile broadband slicing. And the last one is massive machine type communication slicing. So if you want to connect large number of devices, okay, especially in industry applications, we can go for this MMTC slicing. IoT applications everywhere, we can go for this. So this network slicing is one of the important attractive feature of 5G, where based on the user's desire, we can provide the specific network. Coming to the spectrum allocation, we are having licensed band, unlicensed band, as well as shared spectrum. So licensed band, as we know, it is operator owned, so they have to pay the amount to get the license for a particular frequency band. After approval from the ITU as well as from India, TROI is here to take care of this spectrum allocation. And then coming to the unlicensed spectrum, so those who want to have any experience towards this, they can utilize for this unlicensed spectrum. So 500 plus megahertz will be usually coming under this unlicensed spectrum. So shared spectrum, so it is 3-tier access scheme, that is DoD, radars, fixed satellite, etc. Priority access license holders, everywhere it is used. So we have seen so far about what are the features, what are the network architecture, and what are the different frequency spectrums allocated and how these spectrums are allocated. Now we will go for the applications of 5G, because whenever we are going from one generation to another generation, we will be having what are the features and applications will be getting out from the next generation. So we are mainly looking on the applications of 5G. So starting from e-health. So e-health, nowadays we are talking about, that is providing health consciousness to elders, because now both husband and wife are working, so no one else there in the home to take care of the elder people. So we are using e-health facilities, especially to take care of elder people as well as children. So for this 5G plays a major role, and we will be going for connected vehicles, like many autonomous vehicles can be connected. Okay, if you want to connect the vehicle to the roadside, that is roadside unit, we can have applications. Smart grids, that is in the electrical domain also, we will be connecting smart grids using 5G, which will give enhanced features with the power resources to be utilized in an efficient way, because power is very important resource nowadays, so we have to manage it in an efficient way. So this 5G smart grids paves the way for efficient energy utilization and avoiding that is wastage management is there. And smart cities, now in India we are having a lot of plan towards smart cities, so this 5G plays a major role in the smart cities implementation. Just now only we have discussed about smart cities. So what do you mean by smart cities? You have real-time data collection for urban cities management, that is with respect to the traffic, energy, waste disposal, everything will be considering, and the smart traffic lights control will be there. Autonomous public transport, not only private vehicle, we are also taking care of autonomous public transport facilities under smart cities. Coming to the healthcare, remote surgery and telemedicine application with low latency, video and data. So wearables, like we can have some specific wearables for the patients who are sick, and they can be monitored all the time. Okay, so that is real-time monitoring can be done using this healthcare facilities. And automotive, that is autonomous vehicles using 5G for developing both vehicle side infrastructure as well as the roadside unit infrastructure. So we can have an enhancement in the navigation as well as real-time traffic management, because nowadays we can see in many places, in most of the areas where we are having that signal control, even though there are vehicles or not, never bother about it, we have to wait for our signal to turn green, then only we should move forward. But in this real-time traffic management, it will assess the traffic based on the availability of traffic. It will modify the traffic control. Then vehicle to vehicle communication, so it's very important nowadays, because every day we are hearing a lot of news regarding this accidents. So we should make it smart to have vehicle to vehicle communication in order to avoid accidents. Next, coming to the industrial IoT. So real-time monitoring of industrial equipment is very important again, otherwise we will lose a lot of amount that was invested hugely on the machines. So if you want to safeguard all our machines and also to increase the productivity of the industries, we can go for this industrial IoT. So smart factories, like smart cities, now we are entering into smart factories connected machinery and robotics. So robotics is coming to the picture, which will take care of all the activities starting from this lifting everywhere and taking care of the safety, because we are losing some human lives, say for example some underground bugs and all. We can lay this robotics in order to avoid the human loss. Coming to the last one, that is augmented reality and virtual reality, because we want to have an experience of imaginary along with the real, means we can go for augmented reality, whereas virtual reality is purely imaginary part. So this will be having the immersive experience, especially towards education purpose, gaming and training the students. So these are all the different applications of 5G. So what are the impacts of 5G on various sectors? Starting from the very basic telecommunication, so we can go for enhanced network capacity, so ultra fast speeds and better coverage. So this is very important aspect from the user's perspective. Next, healthcare. Already mentioned that improved patient care can be done through remote monitoring, telemedicine application and real-time diagnostics, so that unnecessarily we can avoid the travel for patients, as well as we can avoid the delay and unnecessary loss of human life, because in diagnosis itself we are taking more time, so that we are losing many human lives. So if you are reducing that diagnostic time, then we can go for apt medicine at the right time to safeguard the humans. Automotive, that is enhanced safety and efficiency in autonomous driving and vehicle communication, it's there. And manufacturing, especially in the industries, just now we discussed, increased automation is there, so we can go for better output, better process monitoring, real-time communication. If there is any accidents, immediately it will be communicated or it will avoid it. So everything is possible using this 5G. Coming to the entertainment, that is HD video streaming, immersive AR and VR experiences and live sports broadcasting. These are all the various impacts in different sectors under 5G. Now I am going to handle a specific cases. There is direct to mobile. You have heard about direct to home. No. Similarly, direct to mobile 5G via satellite. So we know about satellite communication. We will be having earth stations. There is a satellite placed in the space. So we are having low Earth orbits, medium Earth orbits and geostationary orbits also. But for this application, low Earth orbit is better. It provides low latency, high speed connectivity. So satellites that are placed in the low Earth orbits will be providing all these facilities. And we are in need of mobile devices, smartphones with satellite compatible chipsets. So we should have smartphones with the satellite compatible chipsets enabled in that. Suitably, the antenna should be erected in the mobile devices. Coming to the ground station, satellite data links to the 5G core network through ground gateways. So we have to link the satellite to the 5G core network for better connectivity. So the major key components for this direct to mobile 5G is, we are in need of LEO and geostationary orbit for broader coverage. We know very well, if we want to cover the entire globe, we can go for this geostationary orbit satellite. Then mobile devices, 5G compatible smartphones, then built-in satellite chipset or external antenna to be there. Then only we can able to get the information from the satellite. So network infrastructure, so we should have ground stations to transfer the data between satellite as well as 5G core network. So there should be proper communication between the satellite based network and 5G core network. So ultimate benefits of direct to mobile 5G, we are having global coverage that is there. If you are using satellite, obviously global coverage will be increased. So connectivity even in remote areas like mountains, oceans, deserts, we can have good connectivity. Especially for disaster recovery. Nowadays we are facing lot of issues regarding the disasters. So restoring the mobile connectivity when terrestrial infrastructure is damaged. Since we are fully depending on the terrestrial infrastructure, we can restore even under any natural calamity conditions or worst conditions. We can have the network mobile connectivity using this direct to mobile 5G. Seamless mobility. So whether we are moving in aeroplane or moving in ships or in high-speed vehicle, we can have connectivity. There won't be any interruptions while you are traveling. Whatever media you are selecting. And high speed and low, there is these two are the ultimate aims. We should have the highest speed, parallelly low latency. So this 5G speeds and performance, even this underserved locations, that is we can have some weak spots. So if you are going for this 5G implementation, those weak spots will be totally removed and will be having better connectivity. So use cases, we can have connectivity for remote areas. Emergency situation we can able to handle. Post disaster mobile communication. That's what I told. Even under natural calamity condition we will have the connectivity. For travelers we will be having good connectivity. And then connected vehicles, that is if you are having self-driving cars and trucks and all, you can get good services under 5G. So companies leading this charge, SpaceX Starlink. So it provides global internet exploring mobile 5G services. OneWeb, that is satellite based broadband services, expanding to mobile connectivity. So we are linking now satellite communication with mobile communication. So nowadays only integrated concept we are looking at. So this is also one kind of integration among the communication. Apple and Globalstar also involved in this process. There is emergency satellite communication in iPhones. So iPhone version 14 and another new versions are underway. AST Space Mobile, so testing satellite direct to mobile 5G connectivity. So these are all the companies now they have involved their work in implementation of this direct to mobile 5G. Coming to the future of this direct to mobile 5G. So expansion of satellite constellations for better coverage. So what are the possibilities? We can have integration with 5G with the intention for more seamless high-speed mobile connection. So seamless as well as high-speed mobile connection globally. That is the main aim of this direct to mobile 5G. And we are having hybrid solutions since we are combining the satellite and terrestrial networks for ubiquitous coverage. Everywhere, anytime, we will be having the connection. Second application we want to discuss is advanced driver assistance system. So this is a technology especially for vehicle safety and user experience. So some of the features are lane departure warning. You know, you might have seen some lanes are there while you are traveling in the highways. So there are different lanes separation will be there. So if you are departing from one lane to the other lane, there will be warning given to the driver so that he can be coming back to the same lane. Next, adaptive cruise control. When vehicle is in mobility, there should be some minimum distance maintained with the vehicles that is coming backside or in the front. So this adaptive cruise control will be taking care of maintaining the proper distance between the adjacent vehicles. Next, automatic emergency braking. So in case of any emergency situation, the brake will be applied automatically and there will be tension reduced for drivers. So there is many adoption technologies in the modern vehicles. So what are the components coming under ADAS? So we are having sensors because we want to sense the information regarding what are the things that is around us. So we will be using cameras, radar, that is we will be finding out what is the distance that particular obstacle is present. So radar is there. Similarly, lidar is there, light direction and ranging, and the ultrasonic sensors will be utilizing. So coming to the software, so we will be having machine learning and computer vision under the software part. For connectivity, vehicle to everything. So if you want to connect vehicle to the nearby roadside unit or to the ambulance or to hospitals or to the doctors, so everything can be connected to the vehicle using this. and we'll be having the actuators for control, that is the steering control will be there, brakes, accelerators. So this diagram shows the advanced features and the components of ADAS. So the role of connectivity in ADAS. So we should have real-time data transfer, because whatever that is happening, the vehicle will be traveling at a high speed, so we would like to transmit at a very high speed. So real-time data transfer is very, very important. Vehicle to vehicle, there is one vehicle to another vehicle to be connected. Vehicle to infrastructure, it is roadside unit or any other hospitals, if you want to give information, so can be done. So vehicle to infrastructure, vehicle to pedestrian. So even to pedestrians we should communicate. Then enable situation awareness, that is we should assess what is the current situation, and decision making should be done at the fastest way. So that has to be there in the ADAS. So coming to the key features of 5G for ADAS. So all the features which we have discussed already for 5G, the same thing will be applicable for this advanced driver assistance system, like ultra low latency, high data throughput, massive connectivity, network slicing. All these features are applied in ADAS. So low latency communication. So here, when there is any collision, our aim should be to avoid the collision. Instead of collision detection and then taking the action, we should go for collision avoidance. So we are in need of low latency communication. So time sensitive, if there is any vehicle suddenly coming or any pedestrian is suddenly entering, so immediate decision making should be taken care, so that we can go for avoidance of collision. So again, edge computing plays a major role, since this is the data processing at the edge, which is reducing the dependency on the cloud and improves the responsiveness. So immediately we can go for the responses. So network slicing, again customized dedicated networks can be utilized for ADAS. So three features are there: vehicle to vehicle, from one car to another car we can have exchange of data regarding if there is any collision to happen, we can prevent it. So in advance. So traffic flow can be managed efficiently and optimized routes can be taken care. So vehicle to infrastructure. So real-time traffic signals. So we have to take care of road conditions and infrastructure awareness. So that comes under vehicle to infrastructure. Vehicle to pedestrian also we should take care, because sometimes in most of the accidents pedestrians are highly affected, because they may be walking on the roadside but they are not aware of a vehicle which is coming out of control. So these kind of things can be totally removed using this vehicle to pedestrian communication. So it prevents accidents involving the pedestrians. So what are the security features in ADAS? So autonomous driving is here. So if you are having autonomous driving, so the entire system will be taken care of automatically. We need not to depend on any drivers. So driver based mistakes will not be there. We can completely avoid it. So because of that, collision avoidance will be there. So instantaneous feedback, since we are traveling at a very high speed and real time data transfer is there, we can go for immediate feedback in case of any congestion over the road due to any sudden any other natural situation is there, natural calamities are there. So we can go for this collision avoidance. So we will be getting the real time data updates using 5G. For the ADAS using 5G, especially for traffic management, so real-time traffic data will be having, so which will be helpful for managing the quality of this automobile industry. That is, will be having fearless driving, okay? And then dynamic route adjustment. So if there is failure in a particular route, or there is any obstacle detected, okay, we can go for alternate route. So the respective vehicles will be receiving the updates real time. That is dynamic route suggestion can be done. So we need not to wait for a so long period. We will be having efficient driving as well as we can reach the destination at the correct time. So optimized traffic lights can be used. So smart traffic lights suggested in the real time can be implemented. So for improved driver assistance, remote vehicle diagnostics. So most of the problem, the driver while he is driving the car or any vehicle, he is unaware of the vehicles that is coming. Some vehicles may be suddenly entering into the area, so he is not able to have the control. So these kind of incidents can be completely avoided using the 5G. So driver monitors, because some of the drivers mistakenly by tiredness they may be sleeping, so there will be some alarm system introduced or some very high level safety systems will be introduced for monitoring the driver behavior. So this also will avoid the accidents. So these are all the improved driver assistance system using 5G. So edge computing already we have discussed. So processing the data closer to the source. Instead of waiting for a so long period for the cloud servers to get the data, we can have all the resources available closer to the source. So lower latency for taking the critical decisions. There is automatic braking can be done. So lane giving, that's what, if it is deviating then warning will be given. So all these things is possible because of this edge computing feature of 5G. So role of 5G in autonomous driving, it enables fully autonomous vehicles. We can go for that enhancement, we need not to depend on the driver. Everything will be automized. So real-time data sharing with other vehicles and infrastructure is a major role of 5G in autonomous driving. So there are also equally challenges. So we have to ensure safety, reliability and security. We should rely whatever system you are introducing for this autonomous driving, you should have the proper reliability as well as security. So potential risk coming with this ADAS are data breaches, cyber attacks. Definitely whatever we are doing, whatever innovation we are doing parallelly, the attacks also equally growing. So we should find alternative solutions for having this cyber attacks and we should take care of the privacy issues. So we should go for appropriate encryption methods for having the security, and we should have high-end secure communication protocols, and there should be regular updates for all the protocols which we are applying. So this is with respect to the security concern. So the future of ADAS with 5G is, there is a transition from level 3 to level 5 using this autonomous driving with 5G support. So there is no doubt in the future we will be having 5G applications implemented everywhere. So integration with smart cities. So smart city infrastructure can be definitely developed using this ADAS for better transportation management. Okay, so far we discussed about applications, and equally there are challenges in the deployment of 5G. So infrastructure we should spend a lot, because we should erect that small cells to have the coverage within the particular area. So densification of cell sites, that is we should go for more number of cell sites and extensive fiber backbone. Spectrum availability, that is we should go for right frequency band based on the user's application for the global 5G deployment. Again, coming to the security concern, since we will be going for more number of devices to be connected, security is a major concern and private issues ought to be taken care. So investment in the infrastructure will be very high. So we have to upgrade all the existing networks, and there should be proper smoothening gradually from the lower generations to the higher generations, because now we are having 2G mobiles in use. So some of them still using 2G mobiles. So we should have proper upgradation and smoothening between different generation as well as the devices. So we should adopt regulatory issues, standardization, global compatibility, and we should get proper approval for the spectrum allocation from the regulatory bodies. So coming to the future trends and research areas, now only we are talking about 60, but there is a parallel research going on 6th generation. So exploring the next generation, we are focusing on terahertz. So this millimeter wave and application is there, no? So there is terahertz communication, AI integration. Nowadays everywhere we want to integrate our surroundings with the artificial intelligence, an extreme level of automation. So integration with the AI and machine learning is one of the important feature, and we should move towards that for getting better experiences and also for network optimization. Then quantum communication, again one of the booming technology. So quantum technologies, especially to enhance the security as well as data transmission, and edge computing. So enhancing that is we have to avoid the latency and improve the performance by processing the data very closer to the end devices or users. So these are all the future trends and research areas towards 5G. So coming to the conclusion, definitely this 5G will be having a great revolution under various industries, mainly because of its higher speed, low latency and massive connectivity. So we are having a lot of opportunities, especially in the field of IoT, autonomous systems, smart cities and advanced healthcare solutions. So these are all our ultimate aim to be achieved. So that will be definitely introducing this 5G. So we have to face all the challenges related to the infrastructure protection, spectrum management and other security issues, so that the full-fledged features of 5G we can enjoy the fruits of 5G. As we now move towards 6G, whatever foundation we are laying for 5G will definitely to be evolved and helpful for integrating the emerging technologies, especially for AI and quantum computing. So now we are going towards 5G with the perspective of having the integration to the future 6G towards AI and quantum computing. I think these are the overview of 5G and what are its targets and how we can able to face the challenges. Thank you all of you.
Propagation models. So as we increase the distance, the path loss will get increased. So we have to model the channels properly in order to maximize the communication performance. So as we know, the evaluation of wireless communication starts from the first generation to fifth generation. So in the in the importance of the wireless networks in the modern life are in the communication, in the broadcasting, in the social networking, even wearable devices also comes in all the domains. Even in the education system, medical system, we have the we have the wireless networks and wireless communication. So without this wireless communication, it is not possible to survive in the society. So the communication, the wireless communication and wireless technology plays the major role in all of the domain. So this how the wireless communication comes from the first generation. It is actually introduced in the 1980s. In that time they used the analog technology. It supports only the voice communication. The limitations are the sound quality is very poor and no data service is not done, and security is also very low. In the second generation, it is actually introduced in 1990s. They have implemented the digital technology through the SMS and the MMS, the multimedia messaging. And then here the advantages are the quality improved. The quality is improved and the security is also somewhat it is introduced. And in the limitations are the data speed is very less. The third generation, it is actually introduced in the year of 2000. They have enhanced the capabilities of data. So here it supports the video calling, internet access, and the data speed increased up to 2 megabits per second. So here it supports the mobile broadband as well as the mobile internet. So limitations are the cost of the users are higher. So in the fourth generation, it is introduced in the year of 2010. The data speed increased up to 1 gigabits per second based on the LTE long-term evaluation technology. Here, it supports the high quality of video streaming and the gaming quality is also enhanced in the real-time communication. The limitations are it is very compatible devices are used in the infrastructures. In the 5G communication, in the 5G communication, it is actually introduced in the year of, one second. The 5G communication actually introduced in the year of 2010. It supports the speed up to 10 gigabits per second. It has the applications are IoTs and vehicular communication is actually introduced here, and it is also introduced in the smart cities projects. The advantages are it is transformational to the impact on the industries and enhance the user experience. Challenges: the adaptation to the previous technology to this technology becomes very difficult. So this is the comparison of generations. So as we said, for first generation they used analog, and second generation they used the digital. Third generation they introduced the broadband. Fourth generation they introduced the LTE, and in the fifth generation they introduced IoT. The data speeds, data speed as keep on it is increasing. In the fifth generation it is 10 gigabits per second, and features here, it support the 5G supports the video call, SMS, MMS streaming, and also the IoT support. So these are the available bands. Presently, we are using the many applications. We are using the ISM band, that is the industrial scientific band. It is 2.4 gigahertz. We are using it for the industrial application and medical application, and as well as for the research application. We are mostly using the 2.4 gigahertz. It is a license-free band. And another frequency is also added in the ISM band, that is 5.8 gigahertz, but it is not worldwide accepted. Only in the US countries, it is accept the 5.8 gigahertz has been introduced as ISM band, but still now the European countries has not accepted the 5.8 gigahertz as a ISM band. But in our country, we are using the 2.45 gigahertz as a ISM band. It has been used in almost all the applications. But it lies in the microwave bands. So here we have the traditional, you can see the my spectrum. It has the traditional microwave bands lies from 10 gigahertz to 30 gigahertz. So after the 30 gigahertz to almost 300 gigahertz, the millimeter wave band starts. So it actually lies in the U band and E band, U band and E band. So it comes under the V band. So you can see the frequency spectrum. So frequencies above the millimeter wave are in the lower infrared spectrum and are limited to the shorter as well as the line of sight communication. The